All right, study guide number 10. In number 1. Area equals base times height. Alright, in that shape, 23 is a base. The 32 is perpendicular to it, so it's the height. So the area for number 1 is going to be 23 times 32. 736. Since it's area and these measurements were in inches, it's going to be inches squared, or square inches. For number 2, it's a triangle, so the area of that triangle is going to be 0.5 times the base times the height. And in that problem, the area is going to be equal to the base of that triangle is 4.3. And the height is 5. And it all needs to get divided by 2, which is the same as multiplying by 0.5. So this area is going to be equal to 4.3 times 5 divided by 2. .75, the measurements are in centimeters, so it's squared centimeters. Let's see, number 3, parallelogram has sides 20.4 and 38.5. Alright, so the height corresponding to the 20.4 base is 10.7. Find the height to the nearest tenth of a meter corresponding to the 38.5 base. Alright, so if it's a parallelogram, then the area is equal to the base times the height. So they give you one base and its height. And they're giving you that so that you can find the area. So you take the 20.4 and you multiply it by its corresponding height, which is 10.7. So 20.4 times 10.7, 218.28. So if the area is 218.28, now you're going to use the other base, the 38.5 base that's given to find the height that corresponds to this base. So take your area and make it equal to your new base times h, 38.5h. So you would divide each side by 38.5. And that's 5.67 equals the height that corresponds to that base. And rounded to the nearest tenth, it's going to be 5.7. Number 4 asks for tells you the area of a parallelogram. Area of a parallelogram is 200. So the area equals 200. And the height is 20. Find the base. Take the formula for area. Area equals base times height. Plug in the given information. So 200 equals b times 20. Divide each side by 20. And 10 equals the base. All right, number 5 and 6 ask you for the area of a parallelogram. I'm only going to do number 5 because you're doing both the same way. They give you the coordinates. So what you want to do is plot those points. All right. Put those points on a graph. So you can identify the base and the height of the parallelogram. All right, so you got a point at 1, 4. So 1, 4. Right here. And you got a point at 3, 4. 8, 8. And 10, 8. If you connect the points, you get a better idea of the parallelogram that you're dealing with. So this segment right here, the base of this thing, it goes from 1 to 3 on the x-axis, so this base is 2. All right? The height, remember the base and the height need to be perpendicular to each other. So this dimension represents the height, and it goes from 4 to 8 on the y-axis. So that's 4 units. So the area of this parallelogram, area equals the base times the height again. So the area is going to be equal to 2 times 4. Area of the shape is equal to 8. So for 5 and 6, graph them. Get your base and your height off of your graph. Number 7. Number 7 says an isosceles triangle has an area of 105. So isosceles triangle. Isosceles triangle has 2 congruent sides. So you're given that the area is equal to 105. Base is 14. So this down here is 14. What is the length of each leg? Round your answer to the nearest tenth. So they're looking for this piece right here. All right, if area of a triangle, if the area of a triangle is equal to base times height divided by 2, they gave you the area and the base so that you could find the height. All right, this dimension right here would represent the height, and it's perpendicular to the base. So if you take 105 and make it equal to 14 times h over 2 and solve for h, that will give you the height of this triangle. And from there we'll use the height and half the base we'll use the Pythagorean Theorem to find this missing leg length. So right here you multiply both sides by 2. These cancel out and you're going to get 210 equals 14h. And divide 210 by 14, and 15 is equal to h. So that makes the height of this triangle 15. Okay? 14 is the base, and it's an isosceles triangle, so this piece at the base is 7. So now with the 7 and the 15, you can do the Pythagorean Theorem to find the leg. So you got 7 squared plus 15 squared equals c squared. This side right here. So 49 plus 225 equals c squared. So 274 equals c squared, and if you square root each side, 16.55 is equal to c. Alright, so the question was, what is the length of each leg? Round your answer to the nearest tenth. It's going to be 16.6. Number 8, find the area of an equilateral triangle with a side of 7. Area of an equilateral triangle with a side of 7. So if it's equilateral, all the sides are the same and all the angles are the same. So 7. All of these sides are the same and all these angles are 60 degrees. If you're asked to find the area equals base times height. So your base in this case is equal to 7 and you're missing the height. So this would represent the height right here. If the whole base is 7, and this is an equilateral triangle, then this portion of the base is 3.5. You're looking for the height so that you can find the area. So now you're given the hypotenuse and a leg of a right triangle. So you can use the Pythagorean theorem again to find the height. So 3.5 squared plus h squared equals 7 squared. .25 plus h squared equals 49. Subtract 12.25 from each side. And h squared is going to equal 36.75. So h is going to be equal to 6.06. Alright, so the height of this triangle is 6.06. And up here in this formula, area equals base times height. It's base times height, then it's divided by 2 because it's a triangle. So the area will be equal to 7 times 6.06 divided by 2. $21.2. All right, number 9. They give you the picture of a side of a building. All right, number 9. You're given the picture of like the side of a building. We got 22 here as a base. We got 13.1. We got a height up here of 7. 7.7. Designing a building, you must be sure that the building can withstand hurricane force winds. They're giving you a formula to determine the force placed on a building. Formula is equal, the force is equal to 0.004 times the area of the side of the building times the velocity of the wind squared. And what they're asking for, A is the area of the surface in square feet, V is the wind velocity in miles per hour, how much force is exerted by wind blowing 77 miles an hour. So they're telling you now that V is equal to 77. How much force is exerted by the wind blowing 77 miles an hour against the side of a building? And all of your answers are in tons. So what you're missing in this formula is the big letter A. And that represents the area of the side of this building. So you're going to figure the area of this rectangle, and then you're going to figure the area of the triangle on top of it, and you're going to add those two numbers together. So the area of this bottom piece is going to be 13.1 times 22. So you got one of your areas, 13.1 times 22. $288.20. That represents this rectangle on the bottom. Then you need the area of the triangle above it, and that we'll call that area number 2. And that's going to be base times height divided by 2. So the base of this triangle on top is 22. So you got 22 times its height of 7.7, and you're going to divide that by 2. So 22 times 7.7 divided by 2. That area is 84.7. Alright, so you have to add these two areas together to get the total area of the side of this building to plug into this formula to find the amount of force by a 77 mile an hour wind. So you're 84.7 plus 2, 84.7 plus 288.2, 372.9. So now your force is going to be equal to 0.004 times A, which is 372.9, times 77 squared. The easiest way to do this is to work it backwards from right to left so that you can square the 77 first. And then you can leave all the numbers in your calculator. So 77 squared times 372.9. .004. All right, that's 88.4370. Now that's going to be in pounds. The formula was to give the force in pounds, but the answer choices are in tons. So you're going to take this and just divide it by the 2,000 pounds that are in each ton. So divided by 2,000, that's 4.42 tons. All right, that's answer D. All right, number 10 is a trapezoid. This is 45 degrees. And this piece over here is 5. You're asked to find the area. Area of a trapezoid. Area of a trapezoid is equal to 0.5 times the height times base 1 plus base 2. Alright, so 3 is your height. Base 1, you can call that the top, that's 10. You don't know base 2. Okay? Base 2 is going to be the sum of all these numbers down here. Alright, if this top piece is 10, then this section of the bottom piece is 10. And you need this right here. Now, this diagram is not to scale. It's misleading. But look, this triangle down here is a 45, 45, 90 triangle. This is an isosceles right triangle down here on the bottom. And if that's the case, and one of the sides is 3, then the other side is equal to 3. Alright? It's a 45, 45, 90. So it makes this side right here 3. It doesn't look it because the drawing's not to scale. So that gives you a base 2. This whole number down here is 10, 5, and 3. So this whole bottom is 18. Alright, so your base 2 is 18. So now the area of the shape is going to be equal to 0.5 times the height, which is 3, times base 1 plus base 2 is 28. So your area is going to be equal to 0.5 times 3 times 28. It's 42. Number 11, it's another trapezoid. Bottom's 12. You're told that this is 60 degrees. This is 2. Alright, this is your height. It's missing. And your base 1, the top, it's missing. Alright, so the area again, the area is equal to 0.5 times your height times base 1 plus base 2. In this right triangle over here on the right, you've got the hypotenuse and you've got a 60-degree angle. It makes this a 30, 60, 90 right triangle. Okay? In a 30, 60, 90 right triangle, the hypotenuse is twice as big as the shortest leg. So this short leg right down here, this piece is 1. The other leg in a 30, 60, 90 triangle is the square root of 3 times the short leg. So your height is 1 times the square root of 3, which is the square root of 3. Now, if this piece down here is 1, and it represents this portion of the triangle, and the whole bottom of this shape is 12, then the top of this shape is going to be 12 minus 1, which is 11. So now you've got all your information for the area. So the area is going to be equal to 0.5 times the height, which is the square root of 3, times base 1 plus base 2. That's going to be 11 plus 12. So that's 0.5 times the square root of 3 times 11 and 12 is 23. So I think if they asked for it in simplest radical form, you would take 0.5 times 23, and you get 11.5 times the square root of 3. And if you want that in decimal form, you could do the square root of 3 times 11.5, 19.9. All right, this is simplest radical form. This is decimal form. And number 12. Find the area of the rhombus. Leave your answer in simplest radical form. All right, this angle is 60 degrees, and this piece is 6. All right, area of a rhombus, 0.5 times diagonal 1 times diagonal 2. And if you remember from your notes the other day, in a rhombus, the diagonals bisect each other. So this piece is congruent to this piece, and this piece is congruent to this piece. So if this right side is 6, this left side is also 6. All right? Now, these intersect at 90, and if this piece is 6, and this is a 60-degree angle, it makes this a 30, 60, 90 right triangle again. So if this is 30 degrees up here, this 6 is the short leg of the triangle, and this leg will be the square root of 3 times 6. So this will be 6 square root of 3, and this bottom portion would be 6 square root of 3. So the area of this shape is going to be equal to 0.5 times diagonal 1. Diagonal 1 would be 6 and 6, which is 12, times diagonal 2, 6 radical 3 plus 6 radical 3. And that's 12 radical 3. All right, so in your calculator, if you take 0.5 times 12 times 12, it equals 72 radical 3. And if you want the decimal version of that, then take the 3 square root times 72 is approximately 124.71.